deriving recommendations for the use of agent-based models in engineering design. Agent-based modeling, or ABM, is a powerful approach to study the emergence of complex system behaviors, eliciting them from the atom up. Let us consider for a moment a real-world aircraft design process. As it grows in complexity, so does the number of design teams involved. We may want to study the dynamics that emerge from the interactions between so many managerial independent design entities. So we start brainstorming ideas for a series of real-world experiments that could help us answer our questions. We think about it for a while, and we realize how unfeasible, inflexible, and untimely conducting real-world experiments might be for the purposes of our research. Enter ABM. In the world of ABM simulation, we can attempt to model the more latent features at the core of our system of interest. For instance, we can model the system design process as a network where each node or agent represents a design team. We can model the behaviors of our agents using very basic rules. These rules can be deterministic or stochastically updated and reinforced. We can model our agents as increasingly complex decision algorithms, or AI agents. And we can go as far as to represent each team member or subteam as one agent with specific behavior and interaction rules. One of the main reasons of creating an ABM is to analyze the effect of changes to the system at the micro and macro level. Once we have built our ABM simulation world, we are ready to experiment with different configurations and constraints and track changes in our variables of interest. Although ABM has been around since the 70s, recent years have seen an increasing interest in the applications of ABM for socio-ecological and socio-technical research. Engineering design has not been indifferent to this trend, and a wide variety of studies that are relevant for research in design theory and methodology can be found in the literature. However, the scarcity of guidelines on best practices for ABM in engineering design could work against the quality of the findings they produce and the embracing of ABM as a useful tool by future design researchers. In this work, we discuss a high-level framework for best ABM practices in design research that seeks to ensure validity, interpretability, reproducibility, and more. We build upon Anu Maria's 1997 description of the modeling and simulation process to derive recommendations for ABM use in engineering design research. In general, it should be understood as an iterative process in which modeler and analysts loop across real-world observations, model development, simulation experiments, findings, and possible alterations to the real system. For a closer look, Maria breaks down the modeling and simulation process in 11 general steps. A clear description of how a modeling and simulation article tackles each of these 11 steps is an endorsement of its quality. We reviewed 21 articles on ABM use in design research and analyzed how effective they were in providing details on how each of these steps was carried out. The findings, ABM use in engineering design literature, score low in describing 3 of these 11 steps. Collect and process real system data, validate the model, and document the model. Nevertheless, how much the completion of each step is required depends on the objectives and scope of the work, and it should not be considered a deficiency. Let us now expand on some of the considerations for future ABM use in design. Specific to ABM, an appropriate minimum level of validity can be reached by having the output of the ABM compared with the output of another model, previous findings, and experts' opinions. Usually, validation of emerging macro-level behaviors is more imperative than validation of micro-level rules. The value of ABM comes from maintaining micro-simplicity and parameterizability. These two features make ABM stand out as an early means for a hypothesis generation. We also emphasize how proper documentation and sharing of ABM is essential to help readers and researchers understand and reproduce the results, as well as to benefit from the use of these models in future work. We recommend using the Objects, Design Concepts, and Details protocol as a template for describing and documenting ABMs. Open source examples of ABMs that follow this protocol can be found in the Network for Computational Modeling in Social and Ecological Sciences, COMSES.net, and in NetLogos Modeling Commons library. There is more to good ABM use in engineering design research than what our paper covers. Here are some summary recommendations. Start simple and keep it simple. Good ABM balances realism and simplicity. Aim for consistency and operational validity. Highlight assumptions and limitations of your ABM, and add comments to your ABM source code as you write it. Thank you for your attention.